Okay, today is going to be our new chapter, so make sure when you guys get back, you'll figure out where you are with your new group. But in your table of contents, you're putting a new chapter 4, called Congruent Triangles, and then putting where the new page number is starting for that chapter. The yellow paper that you hopefully collected from class last time, you could glue it in where you're going to start your chapter 4. It's in yellow. And then we're going to complete the problem over here to the right. So once you set up your table of contents, and then in your main part of your section, putting chapter 4, see if you can answer this question, pause the video, and then come back. So here we're saying HIJK is congruent to LMNO. What are the congruent corresponding parts? So it's very important when you're looking at congruency, and this is a 4-sided shape, so 2 quadrilaterals. You need to make sure that you look at how it's given in the sentence of the congruency. Because it says HIJK, that means HI is going to be congruent to LM. So I'm putting tick marks on those two. So HI is going to be congruent to LM. The next set would be I to J, congruent to M to N. Again, I'm just following the order of how it was written in the directions. IJ, congruent to MN. Then I have here J to K, 1, 2, 3 marks there. And then N to O, 1, 2, 3. Those are congruent. And then the last one here, K to H, is congruent to segment O to L. All right, how about the angles? Angle H is going to be congruent to angle L, because that comes first, right? Then we have coming next, I is congruent to angle M. And then I have angle J congruent to angle N, and then angle K congruent to angle O. So as long as you are writing them corresponding, you'll have it correct. All right, so here was the objective. So today we're trying to get through 2.5 and 4.1. 2.5 is needed to start chapter 4 because it lists some properties of equality that we need to use when we start these proofs that we're going to be getting into, triangular proofs. Today we're going to get into basic proofs. So today we're going to name all the kinds of properties of equality used in geometry for 2.5. And then we're going to determine for 4.1 if two figures are congruent by comparing their corresponding parts. There are the two objectives for today again. Our test is this right here, October 23rd, 24th. You will have Math Excel for homework. And then we're going to be building and testing bridges. So this is going to be done after our test. It's going to be a pretty cool project for our portfolio. And we'll talk more about it as we get into it. All right, so you're heading your notebook, ELR 2.5. If you were in class, I would ask you, what do you think deductive reasoning is? And share with someone. So there's a definition for deductive reasoning. It's reasoning provable by making conclusions from previous statements that are true. So you're deducing something from other statements that you know are true. In this chapter that we're learning, we're going to be making proofs from previous statements that we know are true. And that's basically what a mathematical proof is about. It's an argument which convinces other people that something is true. Most important thing is that proofs require justification at every single step. And we're going to see that at the end of class today. So pause the video if you need to write some of these definitions up. All right, now we're taking the pink paper, if you were here last class, to picking that up and gluing that in if you have glue handy. And these are math justifications that we're going to see a whole lot of in our proofs that we're going to be starting today. So we have addition property, meaning if I have two numbers, I could add a number C to both sides and they'll both be the same. Subtraction property, if I have two numbers equal to each other, I could subtract the same number on both sides. See what you think multiplication and division property would be. I know you definitely know distributive property. Pause the video and then come back to see if you have the right answer. All right, so for multiplication, I'm going to do A times C to equal B times C. So I'm multiplying both sides by C. Division property, I'm going to divide by C, both sides, A and B. And then the distributive property we know is A times B plus A times C, wink smile, if you learn it that way also. So these properties here, you are using all the time in your portfolios already, telling me that you are adding or subtracting on both sides, multiplying or dividing. These ones that are in bold, you're going to see a whole lot of. They come up a lot. One is called reflexive property, A equaling A. Another one's called symmetric. If A equals B, then B equals A. And then transitive property, if I have A equaling B and at the same time B equaling C, then I could definitely say A equals C. And then there's also something called substitution property, that if I have two things equal to each other, I can then replace A with B anywhere in that expression. All right, so now we're on that last piece of paper. If you picked it up, it was white, to glue in or to fold it, however you wanted, and then gluing it in. So I'm looking at the first example here. It says fill in a reason that justifies each step. Use the pink paper. So this is exactly what you do on the portfolios. So here we have 1/2 x minus 5 equals 10. This is an equation that is given. So we have two columns all the time for proofs. A statement column, and then the reason for the statement. So that first statement was given to us. Let's take a look at the next one over here. 2, parentheses, 1/2 x minus 5 equaling 20 now. So what property from the pink paper is justifying this one? Well, if you look back, that is the multiplication property. We are multiplying both sides by 2. Okay, next one, how are they going from the previous one up here to get to x minus 10 equaling 20? What did they do there? Well, looks like they multiplied the 2 inside, and that property is the distributive property. And then how do they go from x minus 10 equals 20 to x equals 30? Well, they're adding 10 to both sides, so that's the addition property. Okay, I don't think that was too bad, right? All right, let's take a look at example 2. Okay, here is the picture down here. We have a straight line CDF. We have a ray coming out, and we got two expressions written on them. This was from chapter 1. We all know that both of these angles form a linear pair. So the first thing that they're writing in this proof, remember it's statements and reasons, is they are actually naming the two angles, angle CDE and angle EDF, are supplementary. The reason is angles that form a linear pair, because these are a linear pair, are supplementary. Or we could say angles that lie on a straight line sharing a ray are supplementary. Either one would be fine. All right, let's see if we can fill in the reasons for A, B, C, and D. All right, what do you think the first reason would be for A? Now, this one is not on the pink paper. This one is just like knowing vocab from chapter 1. So why do these angles add up to equal 180? Because that's the definition, I'm abbreviating, of supplementary angles. So sometimes we're going to be using definitions of previous terms in our proofs also. Okay, for B. Now what are they doing? They're saying x plus 3x plus 20 equals 180. So what are they doing to get the x and the 3x plus 20? That is a reason on the pink little paper. They are substitution. They substituted in the expressions for the two angles. All right, how are we getting the reason for C? C, it looks like they are combining like terms. Again, not on the paper, but just logically, we know they're adding x and 3x together. So I write adding like terms. Okay, how are they going now to 4x equals 160? Well, they are subtracting 20. So I'm writing subtraction property, subtraction. And then how do they get to x equals 40 from the one above? Division property. So just pause a minute and take a look at what's going on here. We will be using some definitions from previous things besides new stuff that we're going to be learning. It just takes practice, but we'll get the hang of it. All right, example 3 on the paper. Okay, this is like a standard way that they like to give proofs. They have a given, and then they have a proof. So we are given measure of angle 1 equals a measure of angle 3. So take a look. They even have it with a tick mark that these two angles are equal. And when they want us to prove that AEC, I'm going to do that in blue, this one, equals, I'll do this one in green, DEB. All right, so we have our statement and reason column. So what's the reason for number 1? Pretty obvious. It's given to us. See that on the top? Number 2. This is on that little pink piece of paper. Why does the measure of angle 2 equal the measure of angle 2? That's reflexive. Now, let's see what they're doing here. They are taking angle 2 and adding it to angle 1 and also to angle 3. So what property is that? Addition property, right? All right, let's talk about 4. 4 is a tough one. This is again from chapter 1 now. Why does angle 1 plus angle 2 equal AEC, the one that I have in blue? And why does angle 2 and angle 3 equal DEB, which is in green? I don't know if you could think about from chapter 1, there was something with adding angles together, and that was called the angle addition postulate. Angle addition. And now, why are these two angles going to be equal to each other for number 5? Well, because if they are equal to each other up here, right, they are just basically substituting these things in there. So 5 is substitution. And the proof is done. Okay, here we have a picture of a line segment, X, Z to Y, and we have representations on the top. And it already has, it kind of started the proof, the statement with the reasons. And the first thing they're telling us is that XY equals 42. That's given. So, do you think we're going to be doing with this next one here? XZ plus ZY equals XY. That is segment addition. So we had angle addition before. Now this is segment addition. Okay, how are they now replacing XZ and ZY and XY? Well, that's that substitution. They're substituting stuff in from the picture into those two things there. Those 3 things, excuse me. And now from here down, I think you could fill it in. So pause the video and come back and see if you get it right. Okay, so next one is distributive property. Distributive. Then we have combining like terms. Then there's subtraction, subtracting 12. And then we are division property. And we get n to be 5. Okay, so that was all we needed for 2.5, some basic solving equations from like chapter 1 that we needed. Now we're going to be getting into, finally, our first section of 4.1. How can I prove 2 triangles congruent? Well, as of today, the only way you could prove triangles that are congruent is that all corresponding sides and all their corresponding angles have to be equal, congruent. So there is a new theorem that you need in your notebook called the third angles theorem. So if I have 2 angles of one triangle congruent to 2 angles in another triangle, so if you look at over here, we have A equal D, B equal E. Why would the third angle be the same, C and F? Well, think about it. All the angles in a triangle add up to 180, and if I know what the sum of those 2 are, that third angle must be the same. So third angles theorem is going to be helpful in our proof that we're going to do in the next page. Okay, here is a picture. Copy it down. Things are labeled with tick marks and also numbers. And I'm asking you, are the triangles congruent? So, looking at all the sides, we got this side congruent to this side. We got a 4 equal to a 4, so they're congruent. And we got 6 equaling 6. So we got all sides equal. We need all angles. We got A equaling E. We got B equaling D. Are these two angles here that are vertical going to be equal? Yes. Third angle theorem, we could say, or we could say because they're vertical angles in their spot, they're also equal. So triangle ABC is congruent to triangle DEF. Oh, DEC, excuse me, DEC. Okay, so here's our first proof that we're going to do. There are two different ways to do proofs. One way is to do a 2-column proof like you were just looking at before. I've seen also where students write it in a whole paragraph and explain things. And you're going to see flow charts on Math Excel. Arrows leading into arrows for a flow chart. They're all the same. Either way is possible. So I would suggest copying the picture of the triangles with the given and the prove. And the first thing that we want to do after you do that is write below it 2 columns, statements/reasons. And then once you've done that, you could start the video again. All right, so I wrote my statements on the left, my reason on the right. You must use all the givens. What result can you get from the givens? That's real important. All these givens, I'm going to write in statement in this first line. You could separate them if you wanted to, making 4 different lines, but I'm just going to put them all up in one. And the reason is they are given to us. And what's nice is they already have it labeled on the picture that LM equals LO, right? MN equals this one, ON, and the same thing for the angles. M equals O, this angle equaling this one. So for us to prove triangles congruent, we have to remember from the very beginning of 4.1, all corresponding angles, all corresponding sides must be equal. Okay, so I'm just going to erase this stuff. All right, so what side is left to prove that they are congruent? It's this side right here that they are sharing, LN. So I'm going to write LN has to be equal to LN because they're sharing it. It's the same length. Now take a look at that pink little paper. What is LN congruent to LN about? That is the reflexive property. So right now we have all 3 sides congruent. All right, last thing that we have to get congruent is the angle. Now, we need to name the angle. Can you name this angle here correctly? That is angle MNL is congruent to, and how about the other one over here? ONL. Now, why are those 2 angles congruent in this triangle? Because of the third angle theorem. So the third angle theorem says if you have the 2 angles already congruent, the third one must be the same. So I believe we've proven that the triangles are equal because everything in both triangles are congruent. So I need to state now as my last statement that triangle LMN is congruent to triangle LON, and the reason being all sides and angles are congruent. Now I know you got a lot today for notes. I feel 2.5 is a little bit more familiar to you. It's just the understanding of not forgetting definitions from previous chapters that we've learned. And then we're going to be getting more into these triangular proofs next class also. Okay, so the homework will be Math Excel 2.5 and also 4.1. Please use the Help Me Solve This button. I think you'll do all right, and we'll be doing more of this when I see you next time. Okay, have a great day, everybody.